Welcome to Math with Malia. Today we're doing Savvas enVision Algebra 1, Topic 7, Lesson 2, Multiplying Polynomials. After today's lesson, you'll be able to multiply two polynomials. For the model and discuss, we have this abstract painting with vertical lines, horizontal lines, and 4 different colors, red, yellow, blue, and white. How can we use mathematics to describe the areas of rectangle 1 and rectangle 2? Well, in order to find the area, we have to find the length and the width, right? I could call this one x and y. So then we would find the lengths of each and then multiply them to find the area. What about for rectangle B? So what they want us to notice in rectangle B is this side is composed of 3 different segments. This segment, plus that segment, plus that segment. So we could add up those 3 different segments and then multiply it by the width, and we would get the area for rectangle 3. How does multiplying polynomials compare to multiplying integers? Well, just as we did adding and subtracting, the similar way that we add and subtract with integers, we line up place value or combine like terms. We're going to do the same thing with multiplying. It's very similar to multiplying with integers. So we have a monomial, one term, negative 4x cubed, and we have a trinomial, so it has 3 terms right there, and we're going to multiply them. If, for instance, I had 3 times 4 plus 5, you could do the sum of 4 plus 5. You could also distribute the 3. 3 times 4 is 12, and then we would add 3 times 15, 3 times 5, which is 15. So we're going to use the distributive property with our polynomials. So we're just going to write them like a factor outside of parentheses, and then we're going to distribute or multiply that factor by each individual term inside the parentheses. Now, the tricky part is making sure you know your number sense and your exponent rules. Okay, so there's an invisible 1 in front of the x squared, and we multiply the constants. Negative 4 times 1 is just negative 4. And then if we have our variable terms, remember your exponent rules. If I am multiplying with the same base, what do I do to the exponents? I add the exponents. You could think of it also like I have 3 x's and then I have 2 more x's. I'm going to combine them and get 5 x's. Okay, so that's multiplying negative 4x cubed times the first term. We're going to do the same thing. Again, multiply the constant. So negative 4 times 3 is negative 12. And then use your exponent rules for the variable terms. So x to the x cubed times x, same base, so we add the exponents. That means we have an exponent of 4. And for the last term, again, multiply the constants. So negative 4 times negative 4 is positive 16. And we don't have any more x terms, so we're just going to multiply it by x cubed. And then make sure that your answer is in standard form, which it already is. So our highest exponent comes first and then in decreasing order. Don't forget to watch your signs, this positive or negative in front of the term. Make sure you keep those together. Watch your signs. Also, make sure you're careful that you are not multiplying the exponents. Okay, you multiply the constants, but then you apply the exponent rules because we have the same base. Try number 1. Let's find the product. So again, we're just going to distribute. So I'm going to have negative 2x squared times x squared. Then I'm going to have negative 2x squared times 3x. And then I'm going to have negative 2x squared times 4. Negative 2 times 1 is negative 2. And x squared times x squared is going to be x to the 4th. So make sure you're adding the exponents when we're applying our exponent rules. Negative 2 times 3 is negative 6, so this is going to actually become negative 6 or minus 6. X squared, I'll write it up here, times x, add the exponents, this becomes x cubed. And for the last term, negative 2 times 4 is negative 8, x squared. It's already in standard form, so just make sure to check that you have your exponents in decreasing order. Part B, I'm going to use arrows to distribute, so make sure to check your signs. Negative 4 times 2 is negative 8. X times x squared is x cubed. Negative 4 times negative 3, be careful, it is positive 12. X times x is x squared. And lastly, negative 4 times 5 is negative 20, and then times x. Make sure to check that your answer is in standard form and check that your signs are correct. So these are the common mistakes with multiplying polynomials. It's just careless mistakes. So watch your signs and make sure you're adding exponents when you apply the exponent rules. When you're multiplying your variable terms that have the same variable, you're applying your exponent rules. Example 2, we can use an area model also, just like we do with multiplying two-digit numbers. So if we multiply 15 times 18, we can decompose it and break it down. And so I said 15 is just 10 plus 5, and 18 is just 10 plus 8. Okay, and so now I have this area model that I can fill out. What's 10 times 10? It is 100. What's 10 times 5? It is 50. 8 times 10 is 80, and 8 times 5 is 40, and then we add up all of those partial products, and we get 270. So some people like to use an area model when you are multiplying polynomials. I think it's very helpful. So we're going to do the same thing with our binomials. We're going to split each binomial. You're going to write one binomial going up and down. This is x, and it's a positive 5. And then the other binomial going across the top, x and a positive 8. And then you just fill out your area model. X times x is x squared. X times 5 is 5x. 8 times x is 8x. 8 times 5 is 40. And then you're going to combine all of those terms. And you'll notice in the upper left corner is your highest exponent term. And so you're going to move from upper left down to the lower right, because our lower right area square is the constant. You'll notice in the middle we have these diagonal terms. These are like terms. So your linear terms or your middle terms will be these diagonal boxes that you have to add together. So we wrote it all out. You can just write each individual area out. So then we have 8x and 5x, and then we have the 40. And then don't forget the last step to combine the like terms. 8x's plus 5x's is 13x. So make sure you combine your diagonal terms, your linear terms at the end. And if you use your area model, you just start at the upper left, go down to the lower right, and your answer will already be written in standard form. What is the area of this green rectangle? So again, it's just using algebra tiles as an area model. Okay, so the first binomial is 2x plus 1. That's what we have here on this side. And the other binomial is x plus 3. That's what we have on this side, and you can see the algebra tiles. Okay, and then we're just going to fill in the individual areas. 2x times x is 2x squared. 1 times x is x. 3 times 2x is 6x. And 3 times 1 is 3. So just like we do our area model, it's down here. It's going to be the same using algebra tiles, and I'll start in the upper left, and I'll work my way down to the lower right, making sure I am combining my middle terms. My diagonal boxes are my like terms. I need to add those together. So 2x squared, 1x plus 6x is 7x, and then the constant. I personally like area models. A lot of my students prefer to use area models when they are multiplying polynomials. So let's find the area of these two algebra tiles. Again, you can just think of it like an area model, so I'm going to divide it up like so. And we're going to write the area in each box. 2x times 5x is 10, multiply the constants, and then x times x is x squared. So be careful with that. Make sure you're applying your exponent rules. 4 times 5 is 20 times x. Now I'm going to do 2x times 2 is going to be 4x. And that makes sense because I'm remembering my diagonal boxes should be like terms. And 2x times 2 is going to be, 4 times 2, doing this one, is going to be 8. And then I'm going to write starting from the upper left and work my way down to the lower right. So my first term is going to be 10x squared. Combine my diagonal terms. I'll write it out. Combine my diagonal terms. I will have 24x plus 8. Okay, part B. Let's do the same thing. I'm going to divide it up so it looks like an area model. And then just write the numbers, the areas inside. 7 times 2 is 14. X times x is x squared. 2 times 2 is 4 times x. 7x times 1 is going to be just 7x. And 2 times 1 is 2. And then we're going to write them starting from the upper left. If you can remember to combine your diagonal terms, you don't have to write them all out. Just remember your final answer should have all the like terms combined. So using distributive property, if you don't want to use an area model, we can use the distributive property to multiply polynomials. And I'll show you another way that I like to do it without regrouping. Instead of writing it out, we can just use arrows. So I'm going to show you down here another method you can choose to use. So I'm going to have my first binomial and my second binomial. And when you're using the arrow method, you need to make sure that you are distributing both terms. So I have to distribute the 2x to both terms in the second binomial. So I'm going to write that with 2 arrows. And then I need to distribute the other term. I need to also distribute the 4. So I'm going to have arrows below and arrows above. So now let's just fill it out. 2x times x. 2 times 1 is 2. X times x is x squared. 2 times negative 5 is negative 10 times x. So there's those two terms. Now I'm going to distribute the 4. So 4 times x is 4x. 4 times negative 5 is negative 20. And then we're going to write it all out, combine everything. So starting with my highest exponent, 2x squared, I have negative 10x plus 4x minus 20. Combine your linear terms. Negative 10 plus 4 is negative 6x minus 20. So I call this the arrow method. Just make sure you're having arrows below and above because you have to distribute both terms in the first polynomial. Well, sometimes it might be more than 2 terms. You'll have to distribute every term in the first polynomial. Try it number 3. We're going to do the same thing. So I'm going to use the arrow method first. I'll rewrite it down here. 5x minus 4 times 2x plus 1. And we're just distributing both terms. So let's distribute the 5x. 5 times 2 is 10. X times x is x squared. Distribute the 5x again. 5x times 1 is just 5x, and it's positive. Then I'm going to have my arrows on the top. Make sure you're careful. That's a negative 4. Negative 4 times 2 is negative 8 times the x. And distribute the negative 4 to the 1. Negative 4 times 1 is negative 4. Then write it all out. 10x squared plus 5x minus 8x minus 4. Combine my linear terms. 10x squared minus 3x minus 4. Okay, and part B, let's do that again. I'm going to do the area model just to remind you how to do it. So set up your area model. I have 2 binomials, so it's going to be a 2 by 2 box. Write the first term and the second term in the first binomial. It's a negative 5. And then I'm going to do the other binomial going down the other side. So 2x and a positive 4. And then just find the area of each square inside. 3 times 2 is 6. X times x is x squared. 2 times negative 5 is negative 10 times x. 3 times 4 is 12 times x. 4 times negative 5 is negative 20. Don't forget to combine your linear terms. Your diagonal boxes are like terms. Starting in the upper left, I will write my answer in standard form. 6x squared, 12x's minus 10x's. How many do I have? I have 2x's left, minus 20. Be careful you keep the signs for each term. So you can choose either method, whichever method you prefer. I personally like the area models, but sometimes the double arrows is easier, is faster. Example 4. What about multiplying a trinomial and a binomial? So like I said, sometimes our first polynomial can be more than 2 terms, and we're just going to apply the same rules. So you can see they set it up like an area model. They wrote the first polynomial up at the top, the second one going down the side, and they did the area model the same. So fill out the area of each. But now I have 2 sets of diagonal terms that we're going to combine. So now I have 2 sets of like terms. You'll add 6x squared plus 4x squared is a total of 10x squared. And 8x's minus 3x's will be a total of 5x's. But it's the same process. And as always, write our answers in standard form with the highest exponents first. So we could also multiply vertically, just like we do with integers. So if we're multiplying 312 times 24, instead of decomposing it and breaking it up into pieces, let's just multiply it using the old school algebra, right? And we'll have partial products, and we add up the partial products. We can do the same thing with polynomials. And just like with addition and subtraction, we make sure that we line up the like terms. We have to make sure we're putting things in the right place value. And then you multiply. So now we're multiplying. You're going to do 2 times 4 is 8. 4 times x is 4x. 4 times 3x is 12x squared. And then we move over. And then we do the other multiplication, the other partial products. 2x times 2 is 4x. 2x times x is 2. X times x is x squared. And then 2x times 3x squared. 3 times 2 is 6. X squared times x is x cubed. Then don't forget the final step is we have to add up these partial products. Okay, so then you add those two together and you get this final answer, which is in standard form. So here's a third method you can use, which might be helpful, especially as our polynomials get higher degrees. Okay, we have more terms in there that we're multiplying. You can choose the area model, or you can multiply vertically. So let's practice. We're going to practice multiplying vertically for part A. So I'm going to write the larger polynomial on top, negative 3x squared plus 4x minus 7. And then the second polynomial will be written underneath, lining up my like terms. So I have a 2x. That's going to go under this one. And a negative 5. And remember, I'm multiplying. So I'm going to start with multiplying my negative 5's. So I have 35, positive 35. And then I'm going to multiply 5 times 4x. And that would be, negative 5 times 4x. So that'd be negative 20x. And then I'm going to multiply 5 times negative 3x squared. Negative 5 times negative 3 is positive 15. And then I have my x squared. Now I'm going to multiply my 2x, okay, by each term above. And so again, skip over, hold the place value. 2x times negative 7 is negative 14x. And you'll see, if you remember to hold that place value, I better not put an x because it looks like that's, you can have a 0 there. Hold your 0. Okay, but we're still lining up the like terms even in our partial products, right? Then I'm going to do 2x times 4x. 2 times 4 is 8. X times x is x squared. And we still have one more. 2x times negative 3x squared. So negative 3 times 2 is negative 6. X squared times x is x cubed. Okay. And then we will add these partial products. I get 35. I get negative 34x. I get 23x squared. And I have negative 6x cubed. Let's do part B. I'm going to do the area model if you want to practice this way. Okay, so I'm showing you different methods. Choose the method that you like best. So this is going to be a 3x2 square area model. So I'm going to make sure it's a little bit longer on the top. Okay, my trinomial goes on the top. So I have 2x squared, positive 3x, negative 4. Do not lose the negative. Do not lose your signs for your terms. And the next one is negative 3x squared and positive 1. Find the area of each box. Negative 3 times 2 is negative 6. X squared times x squared is x to the fourth. Remember, exponent rules, we are adding the exponents. Negative 3 times positive 3 is negative 9. X squared times x is x cubed. Negative 3 times negative 4 is positive 12, x squared. Okay, next row. 1, this is easy. It's just multiplied by 1, so I'm just going to write everything else in here. And then to write our final answer, we'll start in the upper left corner, work our way down to the lower right, and make sure we combine our like terms. So I'll have negative 6x to the fourth, negative 9x cubed, okay? And then I do have like terms with my x squareds. So 2x squared plus 12x squared is 14x squared. And I have 3x, and then I have negative 4. It's still in standard form, highest exponents first, and my constant is last. The closure property of multiplication. So remember in our previous lesson, if we are adding or subtracting polynomials, if we start with polynomials, we add or subtract, and then our answer is still a polynomial, it's closed. So that works. Every time we're adding or subtracting, our answer will still be a polynomial. Does that rule apply with multiplication? If I start one of my polynomials is at least more than one term, and I multiply, well, I'm going to get a polynomial in the end. I'm not going to break it down, right? I'm still going to have more than one term. So multiplication is also closed, meaning I will end with a polynomial if I'm multiplying a polynomial. Our application problem, multiplying polynomials. We have a smartphone. It has a screen that has a width of x and a height that is 1.8 times the width. The outer dimensions of the phone are shown. So remember, just the screen is x, and the height of the screen is 1.8 times the width, so 1.8 times x. Okay. And then these are the outer dimensions in red. So obviously the phone is bigger than the screen. And the outer dimensions are 1.8x plus 3 and x plus 1. So write an expression for the portion of the phone that is not occupied. So we want to know all of this, and you can't see that color. Let's do this color. All this area that's not occupied by the screen in this little section, and all of this down here, and that skinny section. So that's what we're looking for. What's the area of that orange section? Well, we need to first find the area of the total phone, right? And then subtract the area of the screen. And then what's left over will be everything else. So the area of the phone is represented by these two polynomials multiplied. And the area of the screen, again, remember, area is length times width. So we're just multiplying those two things. So obviously we're going to have to do our multiplication of polynomials. So let's do the area of the phone first. And I'm going to do an area model for that one. It's a 2 by 2. So we've got 1.8x and positive 3, and we've got x, and we've got 1. So 1.8x times x is 1.8x squared, and I have 1.8x. 3 times x is 3x, 3 times 1 is 3. Write it all out. 1.8x squared plus 4.8x plus 3. So this represents the area of the whole phone. The area of the screen, let's use the distributive property. I'm just multiplying by x, so that just equals 1.8x squared. I'm going to subtract the area of the screen. Line up your like terms. 1.8x squared. There's no linear terms, no constant. So then we subtract because I'm looking for what's left over. Well, the quadratic terms, the x squared terms will cancel out. I'm left with 4.8x plus 3. This is the expression that represents the area of everything else. Try it number 6. Suppose the height of the phone in example 6 were 1.9 times the width, but all the other conditions were the same. So I think this is worded a little bit tricky. So I'm going to redraw the picture and see if this can help. So there's the phone, and here's the screen. I'm orienting it like height. Okay. And we know that the screen is length x. And I think this means the screen, the height of the screen. So the height of the screen then would be 1.9x, 1.9 times the width of the screen. And then I still have 3 centimeters extra for the outside of the phone. So this is going to now be 1.9x plus those extra 3 centimeters in addition to the screen. And then this is still going to be x plus 1. I still have 1 centimeter to get to from the screen to the rest of the phone. So there are our new dimensions, and we're going to see what expression would represent the area of everything not occupied by the phone surface, by the screen. So we're going to multiply again. We're going to do 1.9x plus 3 times x plus 1. I'm going to use the arrows this time to practice a different method. X times 1.9x, that is 1.9x squared. X times 3 is 3x. Okay, and don't forget your double arrows on the top. 1 times 1.9x is just going to be 1.9x. And 1 times 3 is obviously 3. And then writing my final answer by combining like terms, I have 1.9x squared. This will be 4.9x plus 3. And then, so that's the outside of the phone. Let's do the inside. The screen is just 1.9x times x, which is 1.9x squared. So we're subtracting the area of the screen again, right? So those will cancel. My final dimensions of what's left is going to be 4.9x plus 3. So I think what was worded tricky is this was meaning the height of the screen. That's how we get the answer they want. The height of the screen now is 1.9 times. We made it to the concept summary of multiplying polynomials. So remember, you have 3 different options you can choose from to multiply polynomials. You can just multiply using the distributive property, using your double arrows. You can multiply vertically by lining up your terms and then adding your partial products. Or you can use an area model like this and just make sure you're combining your like terms. They're usually diagonal, so combine those like terms. And then your answer is always in standard form. Highest exponents on the left, descending order, your constant is last. If you have any questions, put them in the comments. Make sure to like and subscribe and come back for lesson 3.